Now we talk about contingency table. So say we are given a population and we want to classify this given population with two different criteria. And we want to find out if these two criteria are similar or different. So similar in the sense of statistics. So let us see an example. Suppose there are 500 students who are studying in a college. And at the end of their graduation, we classify them in two ways. First, you can classify these 500 students as science or arts graduates, and second, as their income levels. So you can classify them in three income levels. They earn less than 40,000 on graduation, they earn between 40,000 and 60,000, or they earn more than 60,000. So this is how a contingency table will look like. So you first have classification according to the stream. So you could have art, science, and if you want to add more classification, you can add more classification like law, engineering, and so on. So the total students in arts is 340, total students in science is 160, this total is 500. The second classification you can do is according to income level, that is less than 40k, between 40 and 60k, and more than 60k. So less than 40k, there are 200 students who make the income. Between 40 and 60, there are 200 students. More than 60, there are 100 students. Again, you add 200 plus 200 plus 100, you get 500. So now you split it. So you have the splitting between arts and less than 40k is 160. Science students who earn less than 40,000 is 40 students. Art students who earn between 40 and 60 is 140. Science students who earn between 40 and 60 is 60, and so on. So you have broken up the table. Again, you can add 160 plus 140 plus 40, you get 340. You have 40 plus 60 plus 60, you get 160. Similarly, this 200 comes from 160 plus 40. This 200 comes from 140 plus 60. This 100 comes from 40 plus 60. So you can have as many income levels as you want. Similarly, you can have as many streams as you want. But notice that there are only two criteria to divide this 500. One criteria is in terms of stream, and the second criteria is in terms of income level. Within this stream, you can have as many streams as possible, and within this income level, you can have as many income levels as possible. But there are only two criteria. So the null hypothesis for contingency test is that there is no difference between these two criteria, that is between streams arts and science and the salary the students get. So whether you classify students as arts or science, or you classify students in terms of their salary level, there is no difference. So more generally, you can say there is no difference in classification of sample, which is in this case 500 students. So again, our null hypothesis is that it does not matter whether you classify students as arts or science, or you classify them as salary level. So what does it mean? It means that whether the student takes arts or they take science, it has no impact on their salary level. So that is what independence between these two criteria mean. So whether you take arts or you take science, it has no impact on the salary level. So you can see in this college, 340 students have taken arts and 162 students have taken science. And we are saying that the salary level of these 340 students is same as the salary level of these 160 students. That is same in the sense statistically it is the same. So that is our null hypothesis. So we are going to reject this hypothesis if you run a test of contingency table, and the p-value you get is less than 0.05. So let us see how to run this in R. So in R, first you set the contingency matrix. So the R does not need to know what criteria there is. So it just needs the values in the matrix. So R just needs these values in the matrix form. So first you add the values of the first row. So the first row is this 160, 140 and 40. So 160, 140 and 40. Then you add the second row. Second row is 40, 60 and 60. Second row is 40, 60 and 60. Here NR means number of rows is 2. Byrow is true, means that we are splitting this sequence by row. So when you run this in R, you get a p-value of 1.669 e minus 11. So to run this in R, you first set m like this. You can copy paste this from the description of the video, and then you run a chi-square test. So this is the R command. So we will show how to run this later. So this is nothing but 1.669 into 10 to power of minus 11. So this is much less than 0.05, smaller than 0.05. So you reject the null hypothesis that subject streams and celery levels are independent. So you say that these two things are not independent. That means the celery level depends upon what stream you choose. So you open the new script, go to File, New Script, then you copy paste what you have in the description of the video, and this matrix is the contingency matrix. So say we have 2 rows here, so we write it equal to 2. If you have 3 rows, you write equal to 3. So let us first run these 2 lines. You select them, hit the run button, and you can see this is our contingency matrix. We want to run the R test on this contingency matrix. So for that you have chi-square test running on this matrix M. You select this, hit the run button, and this will give you the result. So let us see the result. So you have chi-square test M, and only thing you're worried about is the p-value. So here the p-value is very less. This is 1.669 times 10 to the power of minus 11. This is less than 0.05. So you reject the null hypothesis which is associated with this contingency matrix.